One of the constants of software development has been that we always want to do things faster, better, and it's not always obvious that by attempting to do things faster, we actually do them faster. In fact, one of the best pieces of advice that I've got in my career was to go slow to go fast. And now we have this immense potential for speeding up, which is given by AI assistants. And maybe we are moving too fast. So are we? Maybe we should use AI to write better code more slowly? This is what we will go to talk about today. Welcome back to Think Design Work Smart. I'm Alex Bugbot and I'm coming at you from the Mosaic Work Studios, and what I have for you today is a review and reaction to an article published by Nolan Lawson on his blog. Read the tea leaves. I like the name of the blog, Software and Other Dark Arts by Nolan Lawson. And this was posted on 25 May 2026. And I like to go through this article and comment as usual about his ideas, and then my own commentary and my own read on these things. A lot of people seem convinced that the point of AI coding is to write low quality code as fast as possible, spew out barely passable slop, open massive PRs, and merge them unvetted. Ship it. But the thing is, LLMs are very flexible, and you can use them just as effectively to write high quality code more slowly. In fact, if I may interject here, this is one of the things I'm trying to teach participants to our courses on AI powered software engineering, how to use AI in a deliberate way in order to get the best results. And we don't necessarily focus on speed, we focus on solving problems and using AI to help us solve problems with code. And in doing that, we may discuss about performance, about how fast are we moving faster or not. But the reality is that it's very hard to measure. And we've done a whole podcast with Sleepy folks about how you cannot measure productivity in software development and about other software metrics. So if you are measuring productivity in terms of how much code you are shipping, then it gets really, really bad, right? In fact, what I would like to see is more well thought out products, because now we have AI that allows us to explore potential solutions, to explore alternatives, to figure out how to solve parts of the problems in different ways, and maybe in better ways, maybe in ways that are better synced with each other, or in harmony with each other in products. This statement seems completely obvious to me at this point, and I almost didn't want to write this post for that reason, but there seem to be enough people convinced that LLMs are only good as slop cannons that it's worth making the opposite case. I like this. Slop cannons. Okay. If Mythos taught us anything, so he's referring to Claude Mythos, which is a model that is kind of mythical in the sense that Anthropic did a very good job on PR to push it as this incredible model that is so dangerous that will only release to a bunch of people. Now, it's very likely this is only PR, and that the only reason why they did that is because they didn't have the capacity to run it. It was actually too big. But it did catch a bunch of bugs, security issues, and so on. So it's a capable model. It's just not that dangerous, so they want to say, or at least I don't believe so. If Mythos taught us anything, it's that LLM agents are really good at finding bugs. Throw them at a code base enough time and they will find so many bugs that you'll barely know what to do with them. Like many others, I've also found this is true of non-mythos models. Some may be better than others at finding subtle bugs or avoiding false positives, but the fact is that the latest public models from Anthropic and OpenAI are good enough to find plenty of bugs in an unscrutinized code base. The problem is not so much finding the bugs, but instead prioritizing and validating them. And that's the general problem with software, right? Figuring out what makes sense from the product perspective and then prioritizing and validating. For this reason, I have a close skill I adapted from this article's core insight, which is that the more different models you throw at the PR review, the less likely you are to get hallucinations or bogus bugs. The skill says, paraphrasing, run a Claude sub-agent, Codex, and cursor Bugbot to find bugs in this PR ranked by critical, high, medium, low. Once they are all done, review their findings, do your own research to rule out false positives, and write a final report. That's basically it. You can add your own definition of bug if you want. Mine has stipulations about the kiss and drive principles, writing accessible HTML, JSX, using proper indexes for SQL queries, etc. And this is a very good idea. So use skills. Always use skills. They are incredibly useful. Now, I haven't used multiple models for the same problem because I found other ways of dealing with that. So the way you create your prompt influences what you get as the output and can reduce the hallucinations a lot. And honestly, I rarely have problems with hallucinations nowadays. It's just good prompts. This is what helped me. And once again, join us for a course. You learn how to prompt. In my experience, this skill always finds tons of bugs in a PR, and the false positive rate is near zero. You find so many bugs that will be bored senseless if you try to tackle them all. They'll range from critical security or correctness bugs to the more mundane medium-level perf bugs to low-level discounted misleading type bugs. My typical workflow is have an agent fix all the critical and highs with my guidance on the proper solution, then repeat until no critical highs. Skip highs mediums where the juice isn't worth the squeeze. One example, 100 lines of code to fix a narrow edge case. Abandon the PR if it has so many criticals that I realize the whole approach is misguided. Now, it's interesting because the way I do AI coding is mostly as an assistant, not necessarily as an agent. I like to play with agents. I have agents implemented for various things, but they are for much more specific things than implementing a PR and so on. I like the conversation, and through the conversation we get up to the best solutions. That's my experience. When I use this technique, I haven't necessarily seen my velocity go up. Yeah. And it's always very difficult to figure out whether you have velocity. There's a famous experiment made by Jason Gorman who asked multiple teams to do the same kata, so simple problem, with test-driven development and without test-driven development. They did better and faster with test-driven development, but they felt that they were moving slower. And so how much of it is feeling, how much of it is production? In the case of that particular problem, it was easy because the problem is done when it passes a certain number of tests. It's small enough so that you can have those tests ready and that cover everything. But in the case of larger problems, very difficult to see velocity, and also you don't have a comparison level. Like in that case, it's the same kata, so it's the same complexity, but it's for different problems, and we always get different problems in our products. It's not the same, right? When I use this technique, I haven't necessarily seen my velocity go up. If anything, the review process often finds pre-existing bugs, so I end up on a tangential side quest when I'm writing unit tests and fixing subtle flaws that predate the PR. This is the opposite of the 10x productivity slop cannon style of development that most people imagine when they think of vibe coding, but I find it very satisfying. It's a great way to improve the overall health of the code base while also teaching you about the odd corners of it. In my experience, the happy path of a complex architecture is less interesting than its failure modes. And pre-LLMs, this is usually how I got familiar with code base anyway, understanding where the assumptions break down, and then getting my hands dirty to fix it. I mean, maybe. I'm not sure this is necessarily how I would work. I prefer to work on small pieces of code that are either self-contained or that I turn into self-contained. So my first piece of work with an LLM might be to understand the higher level architecture and then to extract a little bit of it, modularize it, and then work on that piece only. And the reason for that is multiple, but one of them is also token economy hallucinations. One of the reasons why you get hallucination is when you're working with a very large context. If you're working with a small context like a module, you don't get hallucinations. So this is why it's good to work at different levels of abstraction and then extract the module and in that module work inside, and it's self-contained, less hallucinations, fewer bugs. And I may go on a bug quest, but if I'm going on a bug quest, it will be different style. It will be, let's figure out this, how these things are connected. Let's generate some tests. Let's review the tests and let's figure out in the tests where we have discrepancies that show us bugs, and also generate the right models and diagrams and domain model and so on, so that you can actually see and find the bugs. So for me, it's two different types of work. One is fixing bugs, one is adding a new feature. If you are the kind of person who is skeptical that AI coding is good for anything, then I doubt this post would persuade you. But if you're the kind of developers who uses agents to write multi-hundred-line PRs that you barely understand yourself, I'd invite you to slow down a bit and try this other, slower style of vibe coding. Yeah, the only issue with that is my feeling is that in many organizations, this is pushed down on people by managers. There was this idea of token maxing, like use as many tokens as possible, which is very silly. It's like giving rewards for people who find bugs. It's very easy to spend tokens. You just spew a lot of nonsense into, throw a lot of context into the assistant, and you'll just spend all the tokens you want. So it's just silly. We are in a period in the AI adoption when strange things happen. But this is a natural period between the initial excitement and when eventually the practices will stabilize and become logical. It's just how these things evolve. Ask an agent how your PR works and how it might fail. Have you tried markdown docs with mermaid charts if necessary? Use Matcox, grill me skill until you understand the entire push request front to back, pull request. You might not be more productive in terms of raw lines of code. You might burn a lot of tokens just to find out that your entire plan was wrong-headed from the start. But I find this style of coding to be a more superpower version of the kind of programming I was always trying to do before LLMs. Careful, methodical, quality-obsessed, focused on making things better for the next coder. So take a deep breath, slow down, try this technique and see if you don't enjoy writing better code more slowly. Okay, so I agree with the sentiment. I disagree with the techniques. I believe that the most important techniques for working with AI are very similar to what we were promoting before AI, and that was incremental thinking, working in small chunks, having a clear goal, focusing on that goal, iterating until you get to the right level of quality. And now you have two ways of implementing that. One is through conversation with an assistant, and the other one is through agents that are conversing between themselves and asking you questions from time to time. Both are valid, both have their places, but for each of these you have to be very, very careful, and you have to know and understand what you are doing. But the general approach is engineering. Take a large problem, split it into small pieces. For each small problem, figure out alternative solutions, iterate until you solve all or 90% of it or 80% of it, and then move to the next one, and so on. And that's basically how you can do things. And then, of course, there are various situations. Like I have a large code base that I need to refactor. You have a different approach. I have a large code base with a bunch of bugs that I need to find and fix. Different approach. However, in all these cases, the key is the same. You take the big problem. I have a big code base. We need to find bugs and fix them. Well, you can go by level of abstraction and focus on separate parts of the code when you go to the lowest level of abstraction, or you can go by modules, but you need to split the problem, the large problem, into smaller problems. However, overall, nice read, good sentiment, and it's just what we always say here, think design and work smart. Okay, this is everything for me. If you want to learn anything, if you want to learn more about these techniques, join one of our AI Power Software engineering courses. Let us know in the comments if you have observations, if you are using AI in different ways, if you have questions. I like to answer questions from you. Thank you kindly for the view, and until next time, remember to think, design, and work smart. See you next Saturday.